Hello everyone and welcome to my channel Learn with Nisha ji. We will be studying relativistic effects in this particular lecture. If you have not subscribed the channel yet, you can subscribe the channel. And if you want to attend one-to-one sessions, you can fill up this form. I will share the link in the description section, right? And you can get one-to-one sessions as well, right? So I would like to mention that this particular lecture we are making as per the request raised by Mr. Abhishek Patnaik, and I really appreciate that yes, you want to learn more about this topic. So please watch the lecture and clarify your doubts. So let's study relativistic effects within an atom arise due to the fact that electrons can move at speeds approaching to the speed of light. Okay, speed of light आपको पता है बहुत ज़्यादा होती है. Okay, so these electrons can move at such high speeds, right? Especially in atoms with heavy elements, like which are having high atomic numbers. Okay, so these effects are primarily related to length contraction and time dilation, both of which are key predictions of Einstein's theory of relativity. Okay, so let's see how these effects come into play in atomic physics. Correct? So the first point is relativistic effects due to length contraction. Okay. So length contraction क्या होता है? It refers to the shortening of an object's length in the direction of its motion when it moves at a significant fraction of the speed of light. ठीक है? बहुत high speed पे move कर रहा है, approach कर रहा है c को, ठीक है? The length of the object is going to shorten. ठीक है? तो Lorentz factor we define as capital L is equal to L naught under root of 1 minus V square by C square. इधर L है हमारी contracted length, L naught is the proper length या length of object which is at rest, V is velocity of the object and C is the speed of light. Okay. So in an atom, electrons moving at speeds close to the speed of light, okay, in high Z atoms, जिनका high atomic number होता है, they will experience length contraction in the radial direction of their orbit. Okay, so their orbits will contract along the direction of motion due to relativistic speeds. Correct? So for heavier elements like gold, uranium, the inner shell electrons, which are closest to the nucleus, they move at significant fractions of the speed of light. This causes shrinking of the electron orbits or a reduction in the radial distance from the nucleus compared to what was expected classically. So very interesting phenomena, right? Second is relativistic effects due to time dilation. So time dilation is a phenomena in which time appears to pass more slowly for an object moving at high velocity relative to an observer at a rest. Okay, तो जो rest पे है और जो हाई वेलोसिटी पे मूव कर रहा है दोनों के केस में टाइम डिफरेंट स्पीड से पास ऑन हो रहा है ओके सो लेट्स हैव एन इक्वेशन t is equal to t naught upon under root 1 minus v square by c square. Here t is the time observed by moving object, t naught is time observed by stationary observer, v is velocity of moving object and c is speed of light. Okay, so particularly for an atom, electrons moving at relativistic speeds, time dilation affects the frequency of the electron's movement in its orbit. Okay, so this effect causes a slowdown in the motion of electrons as seen by an outside observer. So lower frequency of electron transitions will be there, spectral lines will shift due to relativistic slowing down of electron orbits. Correct? So very important factor. So let us see the combined effect, okay, relativistic correction in atomic structure. Now, when relativistic effects are taken into account, they lead to modifications in the energy levels of electrons in an atom. So corrections can be seen in several ways. First is orbital shrinking. So as electrons approach relativistic speeds, they are pulled closer to the nucleus due to increased relativistic mass and the effects of length contraction. Okay, energy shifts होते हैं. So it leads to changes in energy levels, particularly for inner orbitals. This results in blue shift in the X-ray spectra of heavier elements, right? Then there is fine structure splitting of spectral lines. Fine structure, it can be explained by these effects, okay? fine structure constant which describes the strength of electromagnetic interaction. It plays a role in these shifts, especially for high atomic number atoms. Okay. Last is relativistic quantum mechanics, quantum electrodynamics, and the relativistic Schrödinger equation, that is Dirac equation, describe these effects more accurately, predicting the changes in electron energy and orbital radii. Right? Fourth is relativistic effect examples in heavy atoms, okay, like gold and uranium. They become more noticeable, like in gold. Gold is having an atomic number of 79. Inner electrons travel at speeds close to zero point 0.3 C, okay, leading to noticeable relativistic effects. So gold exhibits yellow color due to relativistic shifts in the electronic structure. Uranium, जिसका atomic number है 92, it exhibits even more significant relativistic effects, particularly in X-ray spectrum, due to even faster moving electrons. Okay, so effects हैं relativistic effects like length contraction and time dilation. They significantly influence the behavior of electrons in atoms, especially in heavy elements. These effects lead to changes in atomic radii, energy levels, and spectral lines. Okay. जो लाइट एलिमेंट्स होते हैं उनमें ये इफेक्ट्स नेग्लिजिबल होते हैं. दे बिकम क्रूशियल फॉर accurate description of atomic structure and spectra for heavier elements. Right? So this is all we have. So if you have not subscribed the channel yet, you can subscribe the channel and stay tuned for more informative lectures.